Hi everyone, it's Math with AUB. Today's frame is on ellipse. Ellipse from conic section ellipse. How to find its eccentricity, distance between foci, distance between major axes or distance between vertices, co-vertices, and how to utilize length of lattice rectum. What is the relation of A, B, and C? What do you mean by major axis, minor axis? Let's see the start of ellipse from the very basics. Our question number 1 reads as if ellipse is 9 times x square plus 30 times y square is equal to 117. Find the distance between foci, distance between vertices, distance between co-vertices. Okay, this is the standard equation of ellipse when major axis along x-axis and center is at origin. From this, A is always greater than B. The relation connecting C, A and B is given by C square is equal to A square minus B square, or C is A square minus B square. When major axis along x-axis, when major axis along x-axis, when major axis along y-axis, the equation shapes as y square over A square plus x square over B square is equal to 1. Same restriction, A is equal to B, same elements. This is equation of ellipse having major axis along x-axis. Equation of ellipse having major axis along y-axis. A relation connecting A, B, C is given by this one. Is given by this one. How to find eccentricity is given by C over A, where C is already written, A square minus B square over A, and length of lattice rectum is given by length of lattice rectum is given by 2b square over A. 2b square over A. Okay, without wasting time, let's start. Distance between foci, let's find out. For foci we need C, for vertices we need A, for co-vertices we need B. It is known as, taking this one and explaining, this is our A stands for semi-major axis, while B semi-minor axis. Okay, 2A stands for distance between vertices. 2A stands for distance between vertices. Distance between foci 2C, distance between co-vertices 2B. We are asked to find all this. Our equation is 9x square plus 13 is equal to 117. Okay, transform this equation into this standard form. We need 1 here as a constant. There is 117. Divide by 117. Divide by 117. Mostly they are interchanged. 13 becomes here, 9 becomes here. Let's see and find out how. 9x square divided by 117 plus 13y square divided by 117 is equal to 117 divided by 117. Okay, apply table. 13 times, apply table. 9 times, here it will become 1. So we have x square over 13, y square over 9 is equal to 1. Here A square is greater than B square, that's our value of A square. A square is equal to 30. Sorry, A square is equal to 30. So A is equal to root 13, while B square is equal to 9. So B is equal to 3. B is equal to 3. Utilizing AB and AB, why find the value of C? C is given by A square minus B square. So C is A square, means A square is 13, B square is 9. 13 minus 9, C is equal to 4. So value of C is 2. So value of C is 2. Utilize here. Distance between foci is given by 2C. We have value of C is 2. 2 to the 4. So distance between foci is 4. It is given to us. Answer is mentioned. Distance between vertices. Vertices means A. 2A. 2 value of A is root 13. Root 13. So it is also mentioned. What about distance between co-vertices means B. 2 times value of B is 3, 2, 3 the 6, 2, 3 the 6. We have completed just all these 3 tiny MCQs. Okay. Question number next. Find the eccentricity of the ellipse when axis AXES. AXES stands for plural, both x and y axis. AXES plural, while AXIS stands for singular. Whenever AXIS is mentioned, it must be mentioned x-axis or y-axis. It must be explicitly given. Whenever there is AXES, it means both x and y axis. It means both x and y axis. X and y axis plural. It's all plural. Okay. Mm, If axes are 24 and 32, 32 and 24, as our A is greater than B, that's the value of 2A, 32, while 2B is equal to 24. Axis means major and minor axis, major and minor axis, major axis, minor axis, major axis, minor axis. Okay, from this one can infer A is 16, from this B is R12, B is R12. We are asked to find eccentricity. For eccentricity we need C. C is given by root A square minus B square. A square, A is 16, 16 square, B is 12 square. So it is our 256 minus 144. 256 minus 114, 212, 112. C is our 112. Let's see and find out if factors are possible. 112, table of 2 5 times, 6 times, again 2 times, 8 times, 2, 1 4, 2 7. So we have pair of 2, 2 pairs of 2 and 7 in radical. One pair, another pair, and 7 in the radical. So C is given by 4 times root 7. 4 times root 7. We are asked to find eccentricity. Eccentricity is given by E is equal to C over A. E is equal to C over A. C is 4 times root 7 and A is 16. 16 apply table. So eccentricity is given by 7 over 4. Let me give you a good idea. Eccentricity of ellipse is always less than 1. 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 It is there. So second condition is also given to us when lattice rectum is equal to half of its major axis. The condition lattice rectum is equal to half of its major axis, then find its eccentricity. Then find its eccentricity. Let's see and find out how. Length of lattice rectum, it is mentioned 2b square. Length of lattice rectum, that is 2b square over a. 2b square over a. 2b square is equal to half of its major axis. Half of major axis means 2a. Length of lattice rectum is equal to half of its major axis. Length of lattice rectum is equal to half of its major axis. Length of lattice rectum, half of major axis. 2 to cancel, shift a there. So we have 2b square is equal to a square. Okay. We are asked to find eccentricity. Eccentricity is given by C over A, where C is given by root A square minus B square over A. Okay. Now we have to convert whole this in A. Then A cancelled out. We have numerical value of eccentricity that must be less than 1. Let's see and find out. Find value of B square from here. B square is given by A square over 2. B square is given by A square over 2. Put here and utilize E. A square same minus A square over 2 over A. Taking LCM, it is 2A square minus A square over 2 over A. Okay, 2A square minus A square, there remains only A square. In denominator A and root 2 A square. 2A square minus A square, root 2 I have written separate in denominator, A is already there, so it is A over A times root 2. It's cancelled out. So we have E is equal to 1 over under root 2, 1 over under 2, where it is less than 1, it is valid, that it is eccentricity of ellipse, it is always less than 1. It is always less than 1. It is always less than 1. Answer is mentioned. It's my tiny effort. We have completed circle, parabola, and now we have just get along ellipse. Okay. See and find out what I have for you in next frame. It's all by itself next.